Hello guys, my name is Fernando and today I'm going to explain you the second problem that we got in the last quiz on the classroom. Basically, you guys can think that I wrote a lot on the whiteboard and that I'm not going to explain you this problem, but most likely this problem, what it is that we got this diagram that gave us this problem, and I'm going to explain to you guys. We got this vase and it says that there's a point P on here, so we know that the radius is from here to here, so this one is going to be capital R because it's the radius. From this figure that we got on red, we can know that we have a DQ, DS, and a D. Okay? Basically, we know also that on the little diagram from these lines that we got on the top of this figure, there's an R, which is the distance between here to here. Okay? And actually, what we're looking for is this, the point for the distance between P and this part. Okay? So if you know you're not seeing any numbers of here or any values, you don't have a charge, you don't have a distance, all we got is conceptual values. So most likely this problem is going to be a conceptual problem. Okay? What I did here is that I wrote this formulas, which is lambda, and then we got cosine of theta, and then we got the value for r. Okay? This one is, so in case we have values, we can substitute all the values in this formula, and in the end we can get results with values. Most likely what I wrote on this part is the little procedure that we gotta follow on this problem. And I think after reviewing this problem a lot of times, of the professor Ariano told me that I needed to make the video again because I was like most likely reading a little bit about the problem and then writing on the board. Is that this problem is a little bit hard to understand. For myself, it's like kind of harder to get a problem that does not have values, because I don't know completely the formulas, because I'm not putting values on them, and at the end I don't get a result. Okay? So most likely what I did is put this formula, which is going to be the first one, and in this one we know that we got the constant, and then we got dq, which is dividing by r to the square. And here we got the vector from r. What we're gonna do then, we know we can put the dEz, which is the differential electric fields, equals dE cosine of theta. Most likely in this part from here is that I wrote the values for this, so we can at the end know most likely to apply this procedure in a problem that has value, and it will be easier. In this case, all I want to do is get the unit vector, which in this case we got all these, and since we don't have any values, it's going to be 0, 0, 1. Remember that we have an E, and this is under C. This is the only part that we put on each problem, because in this case it's going to be easier. Okay? Most likely now what we're going to do is that putting all these, we're going to substitute these values for another ones. What I'm meaning with this, it means that on EZ we still have the constant and we have the integral. Okay? But at the bottom it says that we have r squared. So most likely what we have is this one. Well, what I'm going to need to do is going to put r to the square plus c to the square, and this one is going to be 3/2. Why? Because here we have the root, and since we were putting it down, we're going to put, so remember this one is to the square here, we're going to add another half, because when we take a root off, is that we're adding another half. Okay? Most likely, in this case, we're still missing, this is the formula, okay? And we're still missing the part from the top. Okay, so what I told you guys is that we need to put these values, and we know that we have a cosine from theta, okay? So if we get this, what we're looking for is that we need to put the constant that goes up here, because before we had it in this part, we're gonna erase this integral, because I was trying to explain you so we don't get confused. And then we're gonna put the integral over here. We're gonna put the constant, and we're gonna put the lambda, because lambda is dq, and remember that in this part we have a dq, okay? That's why I wanna put lambda in there. And also I'm gonna put z, because z equals the part from the cosine. So from here comes lambda, from here comes the z, and from here comes the k. So the only thing is that we erase the integral in this part, okay? And in this case, remember that we are dividing by ds, so I'm going to put a ds here, easier to resolve this integral, okay? Remember, in this case, ds corresponds, ds has a value, so it corresponds to something. In this case, ds corresponds to 2 pi, it's r, 2 pi r. Okay, that's the value that corresponds for ds. Now we gotta put the values under here, and what we're gonna know is that EC corresponds to the constant, and then it's multiplying for lambda, which is in here the q, and lambda, remember, that has a ds, and a ds comes from this value, and we got 2 pi r. Okay, now we're gonna put the z, because it's multiplying under here. Easier, we're gonna put it on this part, and there's the z. Everything, remember that it was divided for the z, so it was divided for r to the square. And remember that r to the square is c squared plus capital R squared, all this, for the 3 halves. Okay? We can eliminate the values, so at the end I'm gonna remember that we are integrating this part, which is this, and the value from this integrate is going to be easier to put it 2 pi r. Most likely, basically we're going to eliminate this value, this one with this one, and at the end it's easier to know what's the value that we have. Okay, so I'm gonna put here the value that we have at the end. It's easy k. Remember that we eliminate this once, so we got a q. Since the z it's still complete, we're gonna put the z under here. All this is gonna be dividing c squared plus r squared. So we got 3 halves. Okay? I'm going to explain you guys most likely what I did. This is going to be at the end the solution from this problem. But I want to try to explain it a little faster to you. At the end of the first part, we got this formula, and we can determine that dEz equals to dE cosine from theta. Okay? We got all these formulas, you gotta see them. And we got the first step, which is the formula with the integrals, okay? So for this, we got the integral from dEz equals the integral from dE cosine from theta, which is that part that we equals on the top. Only thing is that we gotta take the magnitude, the unit vector I'm sorry, from r. And now it's still the same. We continue with the formula, which is k integrates dq dividing by r squared cosine from theta. Easier, we start putting these values, which is the lambda, cosine, and r, which these 3 values we have them on this part, which we have the cosine from theta, which is from here. We gotta take the we gotta put this part under there, and it's it's easier. Maybe you guys got confused that why I put this z only, since I have an r and have a cosine, which this cosine is going to be eliminated with this one. At the end, we have an r here is going to be eliminated with this one. And the only thing is missing is going to be the z. That's why I put z here. Also, we can know that there's a dq. We have a dq here and equals to lambda. That's why I put lambda here. And the dividing part, which is a ds, I put it on the integrating, okay? Then, that's why I have a lambda and a z. The constant we have over here, so the only thing is that we do is pass it to this part. And to the end, we have the r squared. And the r, this r equals r squared plus c squared. Most likely, we put this value on over here. And it says that since this one is positive and it's supposed to be on the top, we put it on the bottom and it will be 3/2. Because if we take the root, it's going to be 1/2. But since this one is squared, we're going to add the other parts. So it's going to be 4/2, but it's going to be rested. That's why it's going to be 3/2. So most likely this till here is the first part. Okay? Then we start putting the values that we put at the beginning. So remember, lambda was the dq for ds, and ds we determined that the value for ds is this one, 2 pi r. That's why we put 2 pi r here. We got the z, we got the constant, and we got the 2 pi r, which is multiplying here. That's why we eliminate this one with this one. And at the end, the solution that we have, once we took all the parts that are eliminated, we took this solution. So, as a conclusion, I never put conclusion on this type of problems. The only thing is that in this case, this problem was really difficult for me because determining all the values, the conceptual values that we use of this problem weren't easier for me. So most likely at the end, if you review this video, it's gonna get clearly each time that you practice the problem. Because for this explication, I reviewed this problem around 6-7 times, trying to know why we gotta eliminate these values and why we gotta add a new value. But at the end, it's history. When you remember these formulas, remember this, you only need to put the values in this part. Hope you understand the problem, and remember, if you don't get it, what you're gonna do is, as me, try to practice and practice. I practice this problem like 7 or 10 times, and I think still not completely clear for me. But I want to keep trying this one, so at the end, this problem will be as easier as the other ones. Okay? Thank you.